And here we are at page 5 of 2.5. The original notes don't say it, but I'm going to write it in here. This should be a try problem. We already did an example of percentages, so let's see how you do. Let's jump in, and we'll do this one thoroughly in class together. But number 44, go ahead and try this. And again, I will just review some of the things we've learned so far. One is that sometimes you have to bring your own knowledge to the problem. Another is that when you identify your goal, what it is you're trying to find out, if there's one item you're trying to solve for, one unknown value, most likely you're going to translate just to one equation and solve that. But if there's two values that you're trying to find, then you'll want to translate that into two equations, like we did in our first two examples at the top and middle of page 4. Okay, so that's some little hints to get you started on this one. Hit pause, try this one, come back, I'll reveal the actual translated equation and then the final answer as well. One way to translate this problem would be to write it as n plus 0.08 n equals 172.8. The n's nightly cost plus the tax added on based on that nightly cost is the total $172.80. When you solve that, you should end up with a cost of $160 per night before tax. And again, we always want to finish the story here by providing the label. And we'll move now. That was a quick video, so we'll move. Maybe I'll just adjust the screen to the bottom. That's what we'll do here. Just adjust the screen and look at this table. One more little adjustment. Okay, good. Looks in focus. A little thinker alert. So I try to do this to help you out. Again, my goal is to push you this term, get you to be stronger. And if I give you everything, if I give you every answer, if I show you how to do every single problem, you're going to feel like you can't tackle something new unless you have someone else show you how to do it first. And that's not the kind of thinkers and workers we're trying to create. You're going to need to be able to go out there in the real world, and whatever problem, math or not math, but whatever problem you face, you're going to have to gain some skills to tackle those on your own. So, but every once in a while, problems come along where I think you need just a little boost, a little thing to get you started. So I provide these little things called thinker alerts. You're going to have to bring some extra thinking to some of these problems. And the ones I'm talking about are the ones that ask about consecutive integers. So let's talk about what that means for a minute. We know integers, that's all the numbers from negative infinity, the ones that you would count by. Right? They go up by 1 every time. It includes 0, and then you start headed through the positives. Okay, so -6, -5, -4, 0, 1, 2, 3, 4, 5, 6, goes all the way to negative infinity, all the way to positive. Those are your integers. Okay, it's like they count by 1. Consecutive means that they're 1 apart, or they go up by 1 each time, or they're only 1 apart. So consecutive numbers could be like 1, 2, 3. Those are 3 consecutive integers. Or consecutive could also be like -4, -5, -4, -3. Those are 3 consecutive integers. They come one right after the other. So this table here on page 152 walks you through some of the phrases and the algebraic expressions dealing with consecutive integers. So 2 consecutive integers, and an example here might be 13 and 14. The way you'd represent that algebraically is you'd let x be the first number, and then to represent the second consecutive integer, you'd do x plus 1. Okay? So that's a way to represent your 2 consecutive integers. What if you had 3 consecutive integers? Well, you'd start by representing the first one with x, then the second one would be 1 up, because that's what consecutive means. It goes up by 1, so x plus 1 would be your second one. X plus 2 would be the third consecutive integer. So you might have -8, go up by 1, that's -7, go up by another one, that's -6, but it's the original up by 2, okay? So, and so it kind of walks you through that. 2 consecutive even integers, that means it skips 2, okay? Or odd integers. Now I have a little bit of issue with this. It's not critical here at our stage for Math 60, but how could we absolutely guarantee that we're getting evens versus odds if we have the exact same translation? Okay, so one of the things that I was taught, and you'll need it later on, but not necessarily for these problems that we're doing today, but to guarantee the even, make the first one 2x. Okay, and but then your answer has to be 2x. Your answer isn't x. Your answer is 2x. And then when you add, go to the next even, it would be 2x plus 2. So that would guarantee it. So just a little thought. Don't worry about it too much. If that doesn't make sense to you, don't worry. Just use what the book gives you. It will get you through what you need to get through right now at this stage in the game. 3 consecutive even integers. You'd start with 1, you'd skip 2, then you'd skip 2 again, which means you're really skipping 4 from the original. 3 consecutive odds. You start with 1, you skip 2 to get to the next odd. Then to get to the next odd, you'd skip 2 again, which is really 4 away from the original. So, page 152, use that as your help when you get to those questions in the assignment that tell you about consecutive integers. And this is another example of why it's important to skim or read the textbook before you start the practice problems, because you get to catch things like this when they go and you notice, ooh, a table about consecutive integers, all right, and just skim right past it. But then when you hit the problem sets or the practice sets and you hit one that says find 2 consecutive even integers, and you go, whoa, I'm not sure what to do. Wait a minute, I think I saw something about consecutive. Let me go back in the book and find it. So that's one of the reasons why we skim or read the textbook before we start doing our practice sets. Just make sure you have the resources available and don't feel like you're swimming out there all alone. All right, good job, and we'll see you in 2.6.